Imagine a world where sight is your greatest weapon, and a single movement can end a life in less than a millisecond. In the vibrant coral reefs of the tropical oceans, there lives a creature that seems to have been designed in a laboratory rather than by evolution. It is colorful, small, and seemingly harmless, but looks can be incredibly deceiving. Meet the mantis shrimp. This is not just another crustacean, this is the ocean's most specialized assassin. While a great white shark relies on sheer size and an octopus on camouflage, the mantis shrimp relies on something much more terrifying: physics. Today, we are diving deep into the secret life of a 6-inch monster that can punch through glass, boil the ocean around it, and see a spectrum of light that remains invisible to every other living thing on this planet. Welcome to a realm where biology meets the extreme. To understand the mantis shrimp, we have to look at its arms, or more accurately, its clubs. In the world of the mantis shrimp, there are spearers and smashers. While spearers use barbed hooks to snag fish, the smashers have developed something far more complex. Their striking appendages work like a biological crossbow. They don't just use muscle power, they use a spring-loaded mechanism. A specialized saddle in their arm stores massive amounts of elastic energy. When they release the latch, the arm accelerates at 10,000 times the force of gravity. That is equivalent to a human being throwing a baseball into orbit. The strike reaches speeds of over 50 miles per hour in less than 3 milliseconds. But here is where it gets truly insane. The strike is so fast that it creates something physicists call cavitation bubbles. As the club moves, the water behind it cannot keep up, creating a vacuum. When these bubbles collapse, they release a shock wave that produces temperatures of several thousand degrees Celsius, briefly approaching the temperature of the surface of the sun. This collapse also creates a tiny flash of light, known as sonoluminescence. Even if the shrimp misses its target, the shockwave alone is enough to knock out or even kill the prey. If their punch is a miracle of engineering, their eyes are a miracle of perception. Human beings are trichromatic, meaning we have 3 types of color-receptive cones: red, green, and blue. From these 3, we build our entire world of color. The mantis shrimp, however, has 16. They can see in the ultraviolet and infrared spectrums, and they are the only animals known to see circularly polarized light. But why? Why does a shrimp need the vision of a supercomputer? Scientists at the University of Queensland discovered something groundbreaking. The way mantis shrimp eyes detect polarized light is incredibly similar to how we detect cancerous cells. Researchers are currently using the biology of these shrimp to develop new types of cameras that can spot cancer before a traditional biopsy ever could. A creature from the bottom of the sea might just hold the key to the future of human medicine. One of the biggest mysteries for scientists was how the mantis shrimp's clubs didn't shatter into pieces upon hitting a hard shell with the force of a bullet. The answer lies in the Bouligand structure. Their clubs are composed of layers of mineralized fibers arranged in a spiral or helicoidal pattern. When a crack starts to form, it can't travel in a straight line. It's forced to follow the spiral, which dissipates the energy and stops the damage. This design is so superior that it has caught the attention of the US Air Force and NASA. Engineers are now mimicking this shrimp armor to create lighter, stronger body armor for soldiers, more durable car frames, and even spacecraft that can withstand the impact of space debris. Beyond the violence and the high-tech hardware, there is a surprising amount of intelligence. Unlike most crustaceans, mantis shrimps have complex social lives. They can recognize their neighbors by sight and smell. Some species are monogamous, staying with the same partner for up to 20 years. They are intensely curious and highly territorial. They don't just act on instinct, they strategize. If a mantis shrimp knows its opponent is stronger, it will use a visual display to scare them off, rather than risking a fight. It's a level of awareness rarely seen in the world of invertebrates.